Hello guys, this is Matthew, and today I'm just going to show you how to make little mains light indicators using a simple resistive dropper. And they're just convenient. You can kind of stuff it up into some heat shrink tubing onto a cable, or you can do it directly onto breadboard, because all it really is the three components. So just before we begin at all, if you don't know how to make a resistive dropper and calculate out resistor values using Ohm's law, and you're not really very skilled yet at doing electronic stuff, please stay away from AC things. Most projects, as a hobbyist, they just don't require you working with mains voltage. But if you're going to do it anyways, my advice would be to make a lot of these little indicator lights. Give yourself a couple of them that you can use on breadboard, so that you have lots and lots of signs that you are still working with mains voltage. Because all it takes is, it doesn't matter if it's an inch apart right here. If you touch two sides of it, of the mains voltage, it goes across your chest, your heart stops beating properly, just starts quivering, and doesn't matter how much people are gonna pump on your chest, until you have a defibrillator, you're just gonna die. Like, it's literally 95% chance that you'll die if you go into cardiac arrest. So don't mess with mains voltage if you're not familiar with it. But yeah, if you are familiar with mains voltage, then this should just be kind of maybe a little idea that you haven't thought about, putting it in line and stuff. So we'll just be making a simple resistive dropper. So we're just going to basically have our mains coming in. I'm in the US, so it's 110, 120 volts. My house is 122 volts. So we have our resistor, and I'm just going to be using 100K for the resistor. It'll make things very dim. I'll just show you real quick, actually. This is one with 100K in it. But it'll be bright enough to kind of give you an idea, just kind of a good idiot test. Plus, since it kind of likes to flicker, a pretty visual impact. Simple resistive dropper. I'm using 110K. 100K, just because I do like underrunning it, because I want it to last and just know for sure it's very reliable, and underrunning it always seems to help that. So there's the resistor. Then we come down to a light emitting diode down here, and we also are going to have another diode in series, again just to kind of make it more reliable, because if you have a proper diode in here, it won't exceed the reverse voltage of the LED. Like, normally you'd have the reverse voltage being exceeded on your LED, and then that would mean that you would be driving it on both halves of the sine wave. You'd be driving the resistor on both halves of the sine wave. So, but yeah, that's pretty much the whole circuit. And yeah, so we can just start on that. So I'm gonna bring in some blue tack here, or well, white tack anyways. And we'll zoom in here. Alright, so I'm just using a generic, pretty generic diode. Just, what is it? It's a It's an IN5399, but you can really use just, any, it doesn't need to be anything special. So, so yeah, make sure you have your diode direction correct. The banded side should be pointing to the positive of the LED, or if it's on the negative leg, it should be pointing this way. Again, hopefully you know that if you're working with mains voltage, but had to make this for the safety aspect of it. So I'm just gonna trim these down pretty short. And I'm just going to tack this onto the positive lead. If you are unsure which side's the positive lead, it's always the one with the longer tail. And if you've cut off the longer tail and you don't know, the negative is pretty much always the one on the little anvil looking shape. So yeah, just gonna do this. Oh, by the way, just big thanks to Julian on the whole using white tack, blue tack to actually help hold stuff when you're soldering. Yeah, I'm really liking it over using the helping hands. So, all right, that's that side. All right, just go like that real quick. Oops, forgot to trim this one down. Get our resistor. Oh, I'm using a 1-watt resistor for this, but but again, it's just so that I can be sure that I'm underdriving things. This is way overkill on this. As far as if we do the actual math, I mean, you're talking, God, maybe half a milliamp, something like that. Hardly anything at all. But since it'll be running at a higher voltage, you end up with ends up balancing out. Okay. And we'll just do this side. All right, there's that. Okay, just about done, pretty much. I'm going to trim this one down. Let's match it with this for the moment. Here's basically where you could heat shrink things up and then kind of have this plug it directly into your breadboard. Just make sure that you're covering all of the live connections and that you've got good separation. And I'm just going to kind of space them apart there a bit. All right. Oops. Okay. Oh yeah, if you're going to do this, make sure that you don't use a heavy cable. It's just very inconvenient. I had this cable. It was like a replacement tool cable. And yeah, that's working good. It was just a replacement cable for like a cordless drill. And turned out I needed the 3-pronged tool cable because my tool wasn't double insulated, even though it was almost completely out of plastic. It wasn't double insulated. So yeah, anyway, so that was all in there the right direction. Some wire. Still amazes me how Clive just holds everything. Like, don't get me, I mean, we all kind of do that sort of thing, but man, sometimes he'll just be holding two things together with four of his fingers and then holding the solder and his fingers on the other thing, and it's just crazy to me that he doesn't, that works for him. For me. All right. Okay. So we'll just pick a couple of lengths of this. Actually, let's just cut this right in half and then use the group of it, and then we can just heat shrink over the rest when we attach it to the cable there. That's more better. So I already made this video like one time, and I just managed to get the diode backwards. That was cool. Then I was using this heat gun. Let it sit for 5 minutes. Burnt myself to shit. Ended up, yeah, I just, I think that a smarter person probably would have just assumed that the YouTube gods don't want anything to do with them and just ran the other direction. But I'm not exactly the sharpest person in the world. So, anyways, just lop off this end that's already been done. There we go. And don't exactly have proper stripping tools, and because this is just going to be going into one of these little blue screw terminals, I'm just gonna keep this end a bit short. All right. Yeah, let's trim that down. So just kind of come up here and look at how this is gonna go down. And actually, let's just heat shrink this into place how we want it first, and then continue on from there. About there. Actually, let's make sure it's up over the LED a bit there. Just about done. All we need is the to trim these down and solder them together and stuff them into those blue terminals. All right. Let's twist these together a bit. All right. there's that. Okay, cool. Now what's left is the blue terminals, and we're good. Let me cut this down a little bit. I've had too much energy drink. I am shaking like a son of a bitch. This is like just about too big for one of these terminals, but but it works. All right. And we're pretty much done. All right. Well, I hope you guys found at least the idea useful. Be safe and yeah, have a good one.